Hi guys, so welcome to my YouTube channel. So today we solve the problem of minimum deletion to make sorted, right? So there is the given an array. Find the minimum number of elements to delete. Show that the remaining element form a strictly increasing sequence in the same order. Okay, so the problem is very clear. Problem says that we have given an array, and in that array we have to delete the array so we can get the strictly increasing sequence. Strictly increasing sequence, first we understand what is the strictly increasing sequence. So it is, which means if we have the 2, if we have the 1 and 2 and 3, this is the strictly sequence, increasing sequence. If we have 1 1 2 3, then there is the strictly increasing sequence is 1 2 3, not 1 1. Why? Because there is no chance to one array present two times, because that this is not the strictly increasing. Strictly increasing, which means after 1 we have to always greater value. So this is, now in that we can understand the, that means we understand the main concept. What is the concept is how to, that means what the problem says, right? Now we just think and just understand what is the, that means what are the solutions having here, right? So the solutions is very simple. Like at the first time I just think, can we do like start the to loop and then we just have to compare it. When if it will compare, then we can check if the current element is lesser than of the our previous element, so it will remove this. But there is an error and there is a problem. The problem is, if we have do like this, then it may be this is increasing, this is, that means this is small element and this is increasing element, that is fine. But what if 1 2 3 4 5, so in that sequence and in that time we have not got the strictly increasing. Why? Because we can take this two and then we can remove this all. So for that reason we cannot go on that. So now just come on the next approach, what we can do here and what do you think here. So in that, the brute force is very simple. The brute force is, what we can do, we can do, I just pick this one and then this one and then skip this one and then pick this one and then skip this one, which means we can pick and speak, include in a increasing sequence and skip it, right? So how can you do this? This is a very simple approach. Like in that there is a concept and the concept is very simple. Like lis, that means we have the sequence like this is, I will explain. This is the sequence. Now we have the lis which means increasing, that means longest increasing subsequence. 5 6 7, we can get this. Now lis length is equal to 3 and array length is equal to 5. Got it? So minimum deletion is equal to 5 minus 3 is equal to 2. So this is the answer, right? So can we do, and that means this is the very brute force approach here. Now can we do, and in that, in brute force we can go and our solution will go like a 2 to the power n exponential. So that is not the correct approach. Now we can go on the better approach. What we can do in the better approach? In the better approach, if we have to pick and skip, that means recursion, right? So here we can use the dp. Why? The same value not occur the multiples of the time. So for that we can use the dp, right? So the dp, like we have to initially just element can form a sequence length 1, dpi is equal to 1, which means we have to, this all we have to pick as a 1 here, pick as 1, right? Simple one, correct? For every I we check all previous element j. We, for every element we can check the previous element of j. So here is array of j greater than is equal to array of I, this one, right? Then array of I can be added after the increasing subsequence ending at j, right? So here there is a math, we can use the math to just compare the maximum one, right? So I think no need to dry run. If you say please dry run, I will just dry run it. Okay, so the area of, we can see this, we can take this one, right? Now we can choose the dp of these all, right? dp of these all, right? Now 4 6, got it? So 5 greater than is equal to 6, yes. So the dp of 1 is equal to dp of 0 plus 1 is equal to 2, this one. Now for 1, there is no previous element is smaller than 1, got it? So dp of 2 is equal to 1, right? So like this we can do this. I will not, that means write the full of the code, then you will, that means that is the, and then it will make the very long video. So I just explain and write the code of your dp, so you will understand the concept, how can we write this, right? So this is, I just come on the dp approach here, start from the here, right? We can just took this one. Now int, oh sorry, my bad, yeah, sorry, oh yeah. So int n is equal to array dot size, we can just take for the store the data dp of, and to store all the one, and int list length is equal to 1, and for int I is equal to 0, I greater than is equal to n, and I plus plus. For int j is equal to 0, j greater than is equal to I, and j plus plus, got it? So if array of j and array of I, and then dp of I is equal to max of dp of I and dp of j plus 1, and then simple, I just do nothing, list of list length is equal to just max of list length and dp of I, right? And then just return n minus list length, simple one. Now just try to compile and run it, yes, try to submit it. It will take a order of n square. Now see it will pass the orders or not. No, it will show the TLA because it will take the times order of n square. So there is any chance to optimize this? Yes, we can optimize it. And for the optimization, we can use the binary approach, binary search. Simple one. I just go here and try to, that means in the binary search we just have to show the data, and then which means in the last we can do same thing, but the initials we can check as the half of this here, and we can check the here, this is our current element, smaller or bigger, so it is smaller. Okay, now just go on the next, it is smaller or bigger, that is correct. Now just go on the next one, this is smaller or bigger, smaller, okay, so it will replace with this. It may be happen after that there is a chance to all increasing element, right? So for that reason we can take this, and at the end we just have to put one increasing, and then how much we have to put in our boundary, and how much we have to remains. So it will just that means subtract, and then we can get the same answer like same time. Okay, so I just write the optimal code here. So we can do for stage, and then vector int tails, and then for int value of array, right, and then int low is equal to 0, int high is equal to tails dot size, right, while low greater than is equal to high, and int mid is equal to low plus high minus low divided by 2. Got it? So if tails, so if tails of mid value of this is high is equal to mid, else low is equal to mid plus 1, simple. And then if low is equal to tails dot size, then simple one, tails dot pushback of value, and then else tails low is equal to value return array dot size minus tails dot size. Got it? Now just try to compile it. Okay, there is the error of mid. Okay, oh sorry. Now try to compile it, and in here the time is taking of order of n log n, right? So for that reason it will pass out test cases. So I hope you will understand. So thank you so much guys to understand this problem.